Can transfer functions simplify complex electrical systems? Have you ever wondered how engineers make sense of complicated electrical systems? One powerful tool they use is the transfer function. This mathematical concept can really help simplify the analysis of these systems. So, what exactly is a transfer function? It is a way to express the relationship between the input and output of a system in the frequency domain. This means it takes a complex situation and turns it into something much easier to handle. By using the Laplace transform, engineers can convert differential equations into algebraic equations. This transformation is key because it makes the math more manageable. Electrical systems often include components like resistors, inductors, and capacitors. These components interact in ways that can create complex differential equations. For example, in a resistor-inductor-capacitor circuit, the equations can get pretty complicated. However, when engineers apply the Laplace transform, they can simplify these equations into algebraic forms. The transfer function then shows how the output relates to the input, all in terms of a variable called S. This simplification is incredibly useful. It allows engineers to analyze things like system stability and frequency response without needing to solve those tricky differential equations directly. For instance, in a resistor-inductor-capacitor circuit, the transfer function helps engineers understand how the output voltage changes with the input voltage across different frequencies. It also accounts for phase shifts caused by the inductors and capacitors. Another advantage of transfer functions is that they make it easier to work with complex systems. Engineers can use block diagram algebra to combine the transfer functions of different subsystems. This means they can take multiple systems and reduce them into a single equivalent transfer function. This simplification makes it easier to analyze and design controllers for these systems. In control systems, transfer functions play a vital role in designing controllers that achieve specific performance goals. They allow engineers to shape the input-output relationship effectively. Additionally, engineers can use frequency response methods, like Bode plots, to see how systems react to sinusoidal inputs at various frequencies. In summary, transfer functions are a powerful tool for electrical engineers. They help to simplify complex systems into more manageable forms. This makes analysis, design, and understanding of electrical and control systems much more efficient. So, next time you think about electrical systems, remember how transfer functions can turn complexity into clarity.